So this is another example. We are going to do this together. Okay. Using pseudocode creates a simple store application. So you have the pseudocode given, right? Complex condition. Uncle Owen's Droid Emporium sells juice, Droid, and novelty lightsabers. Okay. So, okay. Just don't worry about those wording, guys. It is just for the okay. Fancy words. Okay, just pay attention to what you have to do here. Okay. So droids means I think some kind of light things. Maybe we can look it up. Droids. So some people use that in their Star Wars things. They use it. Okay. So we are not here to talk about that. So it's mostly something related to the Star Wars things, I think. Fictional robot processing some degree, artificial. You know what? I'm not going to waste my time here. So don't worry about that. Okay, so this is kind of a okay. So okay, so we are okay. The recording is good. Right. The Oven offers free shipping to all orders which meet any of the following conditions. The customer purchase at least, that means they have to buy at least one of each. So they have to buy one droid and one light subbies, okay, in order to get free shipping. Or the customer purchase at least three of the same item. So if you see here, the customer at least, so the offers free shipping, okay, they have to meet this condition. What is the condition they have to meet? The customer purchases at least one of each item. So one of each item means they have to buy both of them, right? So they have to buy one droids and one light subbers in order to get free shipping. Oh, if that condition is not met, if they are not buying one of each, then they have to buy at least, okay, three. So it has to be three or more of the same item. So what do you understand from here? What do you see from here? What comes to your mind when you read that? So you have the first one, we know at least one of each. So that means they have to buy both of them. So we need to have an AND operator here, one and this one, right? So we have to have one operator. The next one, or you can buy that, or you can buy this, three of each, but either this or that. Okay, so let's see. Okay. Otherwise, a flat shipping charge of $5 is applied to the order. More instructions on the next slide. So, as I said, I won't. Did you usually do the class exercise on the lab time, or what time you do that during the class time? Hello, are you guys here? So did you guys usually do it during the class time or lab time? Okay. So all right. So we are going to do this question. Okay. So I want all of you to open your Notepad++, guys. So we are going to do this together. Okay. So class exercise 1. Okay. Okay. This is our program that we are going to do, right? Uh, So according to the question, I make sure. Okay. So according to the question, okay, what we are going to do here, the program begins by welcoming the user, then ask the user to enter the number of drives to purchase, followed by the number of light subbers, right? So we have to ask those values from the user. Okay, so from this, what you understand, we need to have two variables, right? One is going to be number of droids and the other one is going to be number of lightsabers. Okay, so we know for sure we need two variables now. Then the program calculates the total cost. So of the order. So total cost order, or you can say total cost order or total order cost, and determines if the customer qualifies for free shipping. The program will then output the total purchase amount, the shipping cost, and the grand total for the order. Finally, the program will thank the user for using the program, ensure your program contains appropriate comments, and follows recommended convention. So let's go back to our Notepad++. Okay. So here what we are going to do now, we are going to declare our variables, right? So what are the variables we are going to have? As we said, we are going to have var number of drives, right? One number of uh, light. Are you guys doing it with me? Then what we need, according to the question, we need to have the total purchase, right? Make sure you guys are using the camel casing, guys. I know you must have been using it, but just want to remind you guys, okay? Shipping cost. Total order. So we got our declaring variable part done. Now what we need to do, we need to do our constant part, right? So declare our constant, right? Okay. So what we are going to do here, var droid. So since we are declaring our constants, what we do, we are going to use capital words, right? Droid price equals 29.99. Then var okay. Next one, regular price. $5. Okay. So we declared our variables. So according to the question, the program is going to get the input from the user, okay, and the header, we have to put the header, okay. So display So this. So we are going to welcome the user by saying welcome to Uncle Owen Droid import. Okay. And also, I would suggest to have a variable, another variable declared as a BR that you can set. Okay. So next, we are going to get the input from the user from okay. So number of droids equals since it's number of droids, we have to say pass int okay and prompt okay. Number of droids we got it. Okay. Then number of lightsabers it's going to be the same. Okay, so we got those two values from the user, right? Now what we need to do, we are going to do the calculation part. Okay, so calculate the total purchase amount. Okay, so that will be total purchase equals that's going to be we need to have a open and closing parenthesis, so that's num droid time droid price, right? So droid price plus okay num lightsabers times okay, so that's the total cost. Then we are going to see if they qualify for the free shipping, right? So determine whether shipping. Okay. So what we are going to do if okay, see if the num droids is greater than at least one, right? So num greater than or equal to one, and num lightsabers is greater than or equal to one. So that is one condition. If that condition, okay, so let's put that in parentheses, the one condition. So they have to meet this condition, greater than or equal to one num droids or num lights is greater than or equal to one. Or either that condition or another condition is num droids is greater than or equal to 3 or num base is greater than or equal to 3. So here what you see, either this condition here we are using the AND operator. Here either this so that we are using the O operator, and also any of these two conditions is met. Either this condition is met or this condition is met. Okay, they get the free shipping. All right. So now we are going to say okay, shipping cost equals 0. Okay. Then we can say document right. Okay, so we do that. Else, if that's not the condition. If they don't meet that condition, then we are going to say shipping cost equals, okay, regular shipping cost, which is $5, right? Okay, that's done. Now we are going to do the calculation. And we don't want the details, right? We have to do that. So let's go back again. So total order cost equals, okay, sorry, total purchase plus shipping cost. Okay, then document right. Okay. Okay. So we did everything. Let's run the program and see what happens. Okay. Obviously, it's not working. 29 something missing. Okay. So line 29. Okay, I'm missing one of this. Okay. So save and did you guys do this with me? $26. Thanks, guys, for the recommendations. I'll do that. I'll follow that. So I'm running my program here. Okay. So number of droids, I'm going to say 1 and 1. So since I said 1 and 1, okay, it's 0. So 29.9. So 8, then 8, 9, okay, then 10, 8, 48, 98. Yes, okay. But yes, I have a few errors. I need to fix that break part here. Okay, so save and run. again. So I'm going to say 1 and 1. So another break I'm missing. Where am I missing my break? Okay, so that's good. Now let's say I'm going to say just 2 and 1. So since 2 and 1 still is greater than 1, so it gives me the um, shipping cost free, right? So let's say I'm going to say 1 and 0. Okay, if I'm entering that, I have a shipping cost and I have the, so you can see that 9999 this part, right? You must be wondering what to do with that. And again, you learned this in your class, right? So let's use the to fix part here. Okay, so let's go back to your code. Okay. Mhm. So here I'm going to do to fix for all of that. Start to remember, guys. Okay. So that way you don't have to have okay. Now run our program again. So 1 and 0. So to fix. Okay. Is that clear? Any question, guys? Any questions? No question? All right. Okay. So now I'll post these examples, guys. Truth tables. So there are a variety of tools that programmers can use to help them sort out complex logical situations and to make coding easier. Truth tables, decision tables, and binary trees. Okay. So truth table is a tool for expressing the results of combinations of conditions. So remember, we did the have money and student ID, right? So according to that, we needed to have both of them true, right? So true, okay, true and true equals true. So this is the only condition applied to that outcome, right? True, false will not be applied. You don't get the discount. False, true, you don't get the discount. False, false, no discount. Okay. So only true and true gives us the discount. Or a not operator, truth table, under the age of 6 true, over 65 true, then you get the discount. Under the age of 6 true, over 65 false, you still get the discount. Under the age of false, 6 false, over 65 true, you get the discount. But both of them are false, you don't get the discount. So that's how the truth table works for the O operator. So that if you see, you will have three, if you see here, 3 outcomes are true and 1 is false. But you still get the discount for all those 3 outcomes. Here, I'm a student, true, we are negating it to false. Not a student, negating it to true. So that is the not operator part. Okay. Decision tables, okay, when we have more combinations, okay, when we have more complex conditions of combinations, then we use the decision table. The decision table states all relevant conditions, true and false combinations of these conditions, and outcomes associated with each combination. So what happens, the number of combination is 2 raised to the power of the number of conditions. That means if we have 2 conditions, okay, two conditions, then you will have 2 to the power of 2, which is 4 outcomes, combinations of outcomes. How can those outcomes be? It will be true, 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 false, false, true, false, false. So that's what it happens here, okay? Then if you have 3 conditions, which is going to be 2 to the power of 3, it gives you 8 combinations of outcomes, okay? That means, okay, sure. Mm, good. Can I go to the next line? Okay. Okay. So now the decision table. So when you have more than 3 outcomes, okay, 3 conditions, it's going to be 8 outcome, right? So how do we do that? Okay, 2 to the power of 3, 8. So that gives you true, 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 false, true, false, true, false, true, true, false, true, false, true, false, 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 true, and false, false, false. That's how you get the combination. So decision table structure made up of rows and columns. Okay, so how we can create our decision table? They are made up of rows and columns. Number of combinations of conditions, 2 raised to the power of the condition. The top section has the row for each condition, true or false. Bottom section has a row for each outcome, performed or not performed. Each column after first represents unique combinations of condition results. Okay. So let's say we have an example. Imagine a customer that is applying to a bank loan. Okay. The decision to approve the loan is based on 3 factors. Number one, the customer's income is more than 40,000. Okay. 40,000 or more. So it's greater than or equal to. Whether the customer has a credit score of 600 or more, whether the customer has had the same job for more than 12 months. So based on these 3 conditions, they will give you the loan. This is the bank's policy on loan application. If the customer's income is 40,000 or more and the credit score is less than 600 and the customer has the same job for more than 12 months, the loan is approved. Or if the customer's salary is more than 40,000, the customer is in the job for more than 12 months, then the loan is approved. If the income is less than 40,000, the credit score is greater than 600, the customer has a job for more than 12 months, then the loan is approved. Any other combinations of factors means the loan is not approved. So how we can create a decision table? In order to make decision table, mark each condition for the column with true and false. Marks X for each true outcome. Leave cell blank for each false outcome. Example, conditions for blank loan. So conditions, so in this case, we have three different conditions, right? Since we have three different conditions, we have three different conditions, okay? That is going to be 2 to the power of 3. So how many outcomes we are going to have? We are going to have 8 outcomes. So 8 outcome means you need to have 8 columns here plus the condition. So that will be 9. Okay. Then we are checking the condition. When you check the condition, if you have 8 outcomes, separate them into 4. True, 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 true. First 4 is true. Then the second half is false. Then next one, alternate with true, true and false, false, true, true and false, false. That way you're not missing any possibilities. Okay. Then alternate with true, false, true, false, true, false, true, false. So we have the conditions. Okay. We have filled out that part. Now we are going to create the decision table, and when we have, wherever we have the true part, okay, so decision table outcome mark. So wherever we have the true part, we are going to mark it with X, right? So true, this combination is good, true, we are marking it with X. We have two conditions meeting here, then it's good. Two condition meeting here, good. This is not meeting because it's not the right one. Here, two conditions meeting, true, and we are leaving. Okay. Then can have relevant conditions. So we have the same condition here. So here, if you see here, these two conditions are already true. So we can make these ones dash. Okay. That's why we are doing the ones here dash. Okay. Third one. But still we have this one. The next one, irrelevant condition columns. Okay, so we are taking off the irrelevant conditions. So if you see here, these two are the same scenario, right? So we don't want to have these. So we are just taking off one part here. Same here, we have two false conditions. We don't want that. We are taking that part off. So true, true, true. And this one is true. We don't need this one. This is true. Okay. So we have our decision table made. So we know here we have the income is more than 40,000 and credit score is more than 600,000. So they are getting the loan. Here income is more than 60,000. The customer is in the same job for more than 12 months. They're getting the loan. Here, income is not good, but the credit score is high and the more than in the same job for 12 months, then they are getting the loan. Okay. Binary trees. Binary trees trail all combinations. Okay, trace all combinations. Start with one condition. So you are going to start with the one condition and split into true and false path. Paths lead to match next condition, irrelevant conditions into true and false path. Flowchart shapes often used to draw. So usually, you know, flowchart, we are using the flowchart shapes to draw the binary tree. We are starting here, checking the condition first with the salary. So if the salary is greater than or equal to 40,000, if that's true, they're checking the credit score. If the credit score is greater than or equal to 600, then the loan is approved. Two conditions met, loan is approved. If that condition is not met, then we are going to check the condition for months at job. If the job is more than 12 months, then the loan is approved. If not, loan denied. You don't get the loan. You don't get it. Okay. False, check the condition. True, if the, so the salary is not right, that condition is not met, so you have to meet these two conditions right. Credit score is true, then you check the condition for job at the same job more than 12 months. If that's true, you get the loan. If that falls, loan denied. Here, if that falls, loan denied. Okay, that's how you create your binary tree. Okay, we have another class exercise for binary tree. Using draw.io, represent the following example. The grade school is organizing field trip to take students to a movie. Show times are 4 and 7 p.m. Group A will see the movie at 4 p.m. Group B will see at 7. Group C are not allowed to see the movie at all. Okay, so how are we going to create a binary tree for that? Group assignment is based on these conditions. If the student has no after school activity, they are in group A. So has school activity or no? If the student has activities and has parents' permission, they are in group B. The student has after school activities and does not have parents' permission, they are in group C. So let's see what they are doing. We are starting here, checking the condition for school after school activity. If they have after school activity, no after school activity, they are in group A. They have after school activity and they have parents' permission, they are in group B. If they have parents' permission, okay, they have school, but they don't have the parents' permission, they are in group C. So they don't get to see the movie. Okay. So how we can use in JavaScript, we already seen how we can use these logical operators in JavaScript, right? So JavaScript logical operators are and, or, and not. Conditions enclosed in parentheses. You have to have your conditions inside the parentheses. And complex conditions. Example, if condition 1, then check the condition 2. So you will have one or more conditions to check, right? Scope is enclosed in braces. So these are the examples. I will post this example, and this is the output we did with the class exercise, right? Short circuit evaluation, we talked about it before, used with two conditions joined by AND. If first is false, no need to evaluate the second one. That's the meaning of short circuit evaluation. So the true and true one, the first one is not meeting the condition, then it's not going to evaluate the second one. Speed up the processing, right? Second or operation, the first one is true, it's not going to check the second one. If first one is false, then it will check the second one. Okay. So when you are writing your program, such the first evaluation is more likely to determine the outcome. So write it in a way that the first one gives the determines the value. Okay. Complex versus nested conditions. Complex conditions used when one action performed with combined conditions is a different action is performed if false. But nested condition is used when conditions lead to a different outcome. So when you have to lead to different outcomes, we use the nested condition. But complex condition, it's one action performed with combined conditions. So to get one action, okay, we use the complex condition. Any questions, guys? Random numbers, okay. What does that? Okay, no, ma'am, is there no question? Okay. Can I do that in Wednesday, tomorrow class, guys? Because I have another class. So can I do that in tomorrow's class? Gurinder Preet, is that okay if I do that tomorrow?